Goodness gracious. Oh, there's like a piece falling out of my microphone. I don't know that that's good. We're gonna see how far we get with this. I told the people that weren't here that I'd let them know what the adjusted assignment would be because I don't know that we'll get through all this because it's kind of a long packet. I also don't know why I didn't do 1 to 2 sided on these. Most of that I always paper, I guess. But, there's some formulas in this. I still haven't received the exams from IB Tech to know what's on the exam, so I'm just teaching everything in the sections, and then hopefully, maybe eventually, I'll receive the exams and can let you know what's on there. Yes.
Are we still doing homework quizzes? I know I just did it internally, but I mean, like, even with all our, like,
Oh,
have or not having. We don't
yeah.
homework.
I don't know. I was thinking about that yesterday. I don't think we're going to do homework quizzes like we did before. I'm thinking I might just check your homework periodically. Let me see your homework. Maybe it'll become like an everyday thing. But since people aren't here today, I'm just going to wait. I'll just have like a homework check, and give you a few points for completing your homework since we have quizzes so often now that I don't need to do that. So I think that's a good question. Okay. Arc length. Arc length means if you have an angle, so here's my angle, right? In a circle, the radius would be what r is here. Your angle is theta. Did we talk about theta in here yesterday? It's very confusing because in pre-cal and this, it's like kind of the same but kind of different, and I keep forgetting what I've done in which class. But theta is just what we call the angle. You usually call it whatever you want, but this one's just calling it theta. The arc length would be the measure of the circle there. So like where the angle intersects the circle, that would be your arc length. And there's just a formula for that. The angle is equal to the arc length divided by the radius. So if they give you 2 of the 3 things, the radius, the angle, or the arc length, you can plug it in and solve for what's missing. We can write it out in words here. Really important that the angle, that theta, has to be in radians, and then that's equal to arc length divided by the radius.
So isn't that the same thing?
It's the same thing, just in words, right? Most of the time, not always, but most of the time, we're looking for the arc length, and they give you the radius and the angle. So I thought we could just solve this equation for s, which means I would just multiply r over, and I would get s equals r times theta, right? That would be, these are the exact same formula, just written in a different way. Follow me on that? You might have to have this memorized at some point, depending on what's on the unit test, because I don't know. So I just put a couple examples here, but probably we just really need to do only one of them, but you can let me know what you think about it. But if I ask you to find the arc length, if they give you an angle and they give you a radius, the length of that arc, basically what section of that circle, is you just take the radius times the angle, but you got to make sure it's in radians. So if it's in degrees, you got to switch it to radians first. So to do number 1 there, if the angle was 5 pi fourths, and if the radius was 20 millimeters, then we would just take the arc length would be equal to 5 pi fourths times 20. And we could simplify that and say 25 pi. And your units, you're talking about the length of the circle, so it's in whatever the length of the radius is. So if the radius is in millimeters, we would say that that section of the circle's arc length would be 25 pi millimeters. The only thing that could make that more tricky is let's actually change number 2. If this said theta equals 45 degrees, let's make it say that instead of whatever it said there. The big mistake that happens is that people take 45 times 12 and get the wrong answer because theta has to be in radians. So when you do r times theta, you have to make sure you change 45 degrees to radians. And so if you don't know what 45 degrees is as radians, you could just take 45 degrees and then multiply by pi over 180. Or that's just pi fourths is what 45 degrees is. Is that true? So that's really as tricky as ArcLink gets if you know the formula, and you're just plugging it in from there. Questions on that? I just found a terrible typo on this packet of notes. Even those of you that took pre-calculus, we did not talk about this formula in pre-calculus, but in this book, they talk about finding the area of a sector. So arc length is finding just the length of this circle, right? Like a chunk of the circumference. Area of a sector means the area, like this chunk of the circle, how much area is that? So area of a circle is pi r squared. But if you just want to find the area of a sector, this is your formula. So again, theta has to be in radians, so that would be whatever this angle is right here. R would be your radius, and then it's 1/2. So it's 1/2 times r squared times whatever your angle is. And again, by the time when we have a test or when we have a quiz, I'll let you know if you need to have this memorized or not. But if you have it memorized, all you're doing is plugging in your radius and plugging in your angle in radians. And so I think I just put a example right there on the next slide here that says a central angle theta is subtended by an arc 10 centimeters long. I found the book says that a lot. Subtended by an arc. That just means here's the angle and this is the arc that kind of intercepts. On a circle of radius 4 centimeters, find the area of the circular sector. So notice they tell us that the angle here is 2.5. Is that in radians or is that in degrees, or do we not know? Because, yeah, there's a couple ways we could say. 2.5 degrees definitely would not be this big, right? If you look at the circle. But also, there's no degree symbol. That's how you really know. There's no degree symbol, which tells you that that's in radians, 2.5 radians. They tell us that the arc is 10 centimeters long. That's this section out here. This is the arc. They're telling us that that is 10 centimeters. And that the radius is 4 centimeters. Do we need to know how big the arc is to do this problem? I don't think that's even in the formula, is it? No. So that's kind of like unnecessary information. We don't really need to know that the arc is 10 centimeters. Because the area of the sector is just 1/2 r squared times theta. And theta is already in radians, so you're really just plugging that in. So the radius is 4, my theta is 2.5. Sorry, I'm just checking my formula here really quick. They are. Well, I copy and pasted a little bit here and there, but yeah, this is all brand new. What? Where'd you go? 20. Does that work out nice to just give you 20? And if we are talking about area, units r squared. So if r is 4 centimeters, area would be square centimeters if you're throwing information there. Sometimes your area is not going to be a nice number, like it's going to be a decimal, or maybe it would have pi in it and you have to decide if you want to multiply pi out or not. But again, arc length and area of a sector are just formulas that you might have to study at some point to know. And who knows, if I ever get a copy of the unit test, sometimes they put formulas on the unit test for you. I'm going to email again today, do my third email, asking for a copy of the exams. I'm guessing maybe they're not in their office right now. I emailed before break and they said, what? Well, the kids aren't in school yet, but I figured that the teachers might be, but I don't know. I emailed before break and I got an email back that said, we're in the middle of finals week, I'll get these to you next week. That was like December 15th. So then I emailed Monday and I copied the dual credit advisor and she said, I'll email also, but I haven't heard back from the person that's supposed to email it to me. So I'm guessing maybe next week. I think most colleges start back. It doesn't. we just keep doing it because it's free classes for you guys. So we just put up with the disorganization. So, what time do we get out of here? 1:24. All right, let's do one more thing here. Or maybe just all of it. What? What's my bad typo? Look. Angular speed of a wheel that is rotating at a constant rate is the angle generated in 1 unit of time by a line segment from the center of the wheel to a point on the circumference. Basically, it's just like the speed in terms of radians. Instead of talking about revolutions per minute, like they're changing it in terms of radians. Kind of hard for us to imagine, which is why we like angular velocity. Linear speed better, which we'll do in a minute. But basically, you just need to know that angular speed means you take the angle in radians, usually, over whatever the unit of time is. And the really great thing about angular speed is it always says, like, give your answer in radians per minute or radians per second. And then you know what you're trying to do. So it kind of becomes just a conversion, kind of like what you've done in chemistry a lot, where you're converting things. Linear speed is a distance, and so it's a lot easier for us to visualize linear speed because it actually gives you something in like feet per second, so that you can imagine it maybe a little bit better than angular speed. And again, it's another formula, and I could be totally wrong, and maybe they don't even test over this stuff, so eventually I might say, oh, we don't have to study that for the unit test. But I know there is a question, I believe, about either arc length or area of a sector on the quiz, so I'm guessing that that's going to be on the unit test as well. But linear speed, you basically just take your angular speed and you multiply that by your radius, but it's just the radius times your angle in radians over your time again, okay? So let's just do an example of this, and then I want to talk about degrees, minutes, seconds, but we might wait to do that tomorrow. Well, who knows? If we have a 2-hour delay tomorrow, why don't I just do the whole thing? Because they're not going to be here anyway, right? Oh, it's so stressful. Look at this lovely wheel I put on here. You can what? Look what, can you tell these are my notes I just typed yesterday? I wrote, suppose that this week is rotating. That should say wheel.
I can't ever remember if wheel has P on the end of it.
It does not. It's not a week, it's a wheel. Suppose that this wheel is rotating at a rate of 800 RPM. If you don't know what RPM stands for, it stands for revolutions per minute. They want us to find the angular speed and then the linear speed. And this kind of goes back to some chemistry conversion stuff at some point. But notice they give us the wheel's diameter is 24 inches, which means our radius would be 12 inches, right? And angular speed is really just converting what they give us, right? They're telling us that this wheel is turning 800 revolutions in 1 minute. I wonder how fast this is. I'm kind of interested to know. We want to change that. Angular speed, we said, is theta over time. So the time it only tells, we're going to just leave it in minutes. But how many, if I'm going 1 revolution, how many radians are in 1 revolution of a circle? 2 pi. So could I say in 1 revolution there are 2 pi radians so that those revolutions cancel out? And I'm changing revolutions per minute to radians per minute. And since they don't tell me what unit to keep it in terms of time, I'm just going to keep it in minutes. We can change it to seconds if we wanted to. But that's just going to be 1,600 pi radians per minute. And normally we don't write out the word radians, but because we're talking about a unit of measure, I'm going to leave it in there. It's really hard for me to imagine why linear speed kind of is something that we visualize a little bit better, maybe. So look at, this is the worst, I believe these are the worst notes I've ever written in my life. Third typo. I knew Mr. Parker was observing me today and all my typos. Find the linear speed in inches per minute and miles per hour, which is just going to be some converting, of a point P on the circumference of the wheel. So the linear speed means it's going to give us the speed if we were out here on the edge of this wheel. That's what it means by point P on the circumference of the wheel. But the formula is the same. To find linear speed, we're going to just take the radius times what we just did, theta over time, which we just did up there, the angular speed. With me on that? So my radius is 12 inches, and I'm going to leave my theta over time as my answer I just found up here. Like we already changed revolutions per minute to radians per minute, so I'm just going to go ahead and say that 1600 pi per 1 minute, I guess, if you want to say. This is going to be how many inches per minute you would be traveling if you were sitting on the edge of that wheel. Which means I think you would be flying off that way. You get 19,200 pi inches per minute. And when you throw the radius in there, it just becomes inches per minute. And if you wanted to multiply pi out just to kind of get an idea of the answer to that, it's like 60,318.6 inches per minute. But it's hard for us to imagine inches per minute, so that's why they throw in, let's convert that to miles per hour, so we can kind of see like how fast you would be traveling if you were tiny enough to fit on the edge of that wheel up there traveling. So then that just becomes, I don't know why I enjoy this so much, but I like to say 19,200 pi inches per minute. We just want to convert inches to miles and minutes to hours. This is just some good old unit conversion chemistry stuff. You could go straight to miles if you want, but I don't know how many inches are in a mile, so I'm going to say I know that there are 12 inches in 1 foot, right? And there are 5,280 feet in 1 mile. You with me on that conversion? So my inches cancel out and my feet cancel out. So that gets me from minutes to miles. Nope. From inches to miles. And then I want to go from minutes to hours. So could I say I know there are 60 minutes in 1 hour? And then I can cancel out those minutes. And I always liked doing this. I feel like I did this more in chemistry than I did in math class. But I felt confident in my answer because if all my units cancel out, I could see that my new units are going to be in miles per hour, and that's what I want. And I'm actually going to multiply the pi out and get a decimal just so that we can get an idea of how fast that's traveling. So 19,200 times pi, and I'm going to multiply by 60 there at the end. And then I'm going to divide by 12, and I'm going to divide by 5,280. And I get 57.12 miles per hour. It's how fast you'd be traveling if you were going 800 revolutions per minute. That's a lot of math to figure that out, right?
Like how many sheets that fits?
Yeah, I don't know. We did a question like this in pre-calc today about a Ferris wheel that was 208 feet in diameter, and I was like, I don't really have an idea of how big that is. And then Bradley Schrader says that that's 7 telephone poles. I don't know how he knows how far our telephone poles are, but he said that that would be Ferris wheel 7 telephone poles apart, which seems like a really gigantic Ferris wheel. And we said that we've traveled around that Ferris wheel in 20 seconds. So imagine a Ferris wheel 7 telephone poles wide, like Seems like a not good problem.
Bradley knows this.
I was just like, oh, 7 Helmholtz. Who would have thought? I'm just gonna stop on this, which means I'm gonna change the homework in terms of degrees, minutes, seconds. And tomorrow, what I'll do is I'll finish those 2 circles that I wanted to write out. I didn't want to do that today because the other people weren't here. That's really wanted to see that. But tomorrow I'll draw those circles out just to kind of talk about radian measures, and we'll finish up talking about degrees, minutes, seconds. Because I feel like there's gonna be a 2-hour delay tomorrow. What's really gonna stink is if there's cancellation tomorrow and I didn't finish this. Whatever. Who wants to be on track anyway, right? So let's figure out what homework we're gonna do.
Well, you're looking at that. Did anyone do the have to? I know we have to. Okay. I know he like stuff, or he's here now. Yeah. So it must not have been that.
I think you can only do this part. So not 23 through 26 yet, unless you remember about degrees, minutes, seconds. Like I'm going to assign that eventually. But the rest of that is over arc length, angular speed, linear speed. So you should be able to do those other problems, and then tomorrow we'll kind of try to summarize the stuff and do degrees, minutes, seconds stuff. Okay? We're already ahead because last year we missed this whole week, right? That's why you know.